So chapter 6, this is the structure. We're going to talk about the list ADT, the list abstract data type. So we're going to look at what's the list, formal specification of the list. There are three types of the list: unsorted list, ordered list, and indexed list. We can use array to implement it. And we look at the application: poker, golf, and music. Right. Binary search algorithms. And we can implement using the linked list, which is the reference-based implementations. Storing objects and structures in files. So, what are the main operations for the list? We said check whether a given item is on our to-do list, for example, right? If we don't want to duplicate things in the list, we go and check, which we normally use the method like contain, find. Insert, we can insert something to the list like the name. Delete, we can delete an entry that matching in the list if the entry is in the list. So when we compare, this is primitive data type. When we compare, we use two equals. This is an operator to compare between int A and int B. So for primitive data type, when you do comparison, like in this case, it's going to be true, because the contents is being compared 10 and 10. But for the reference type, so this is primitive type, the data or the values being compared. Reference is compare the reference. Reference means this is an object. Like if I create a circle, C1, form a circle class template. So I'm going to have the reference to that circle class template. If I do create circle class C2, form the same class template, it's going to point to another class template. When we try to compare this with the two equals operators, it's not going to return true, because it's different objects. But if we assign like C1 equals to C2, so if we do C1 equals to C2 afterward, then the pointer is going to point to the reference of C1 is going to reference to C2. Then if you do two equals comparisons, it's going to return true, because now it's reference to the same object. So we have equals method. Equals method is where you actually use when we want to compare objects and object. Like in the case of C1 equals C2, we don't want to use the two equals operators, but use the methods to compare. And it should return true in this case. An example of how to implement the equals method in the circle class. So pretty much just comparing the radius. Right, the object you can compare many attributes. So in this case, we pick the radius to compare. Return true when they're equals, otherwise false. Ordering objects. So besides checking objects for equality, another type of comparison we need to support sorted lists, we need to be able to tell when one object is less than, equals, or greater than another object. So we need to implement an interface comparable to the class. Like for example, if the circle need to compare for less than, greater than, or equals, then the circle class has to implement comparable interface. Now, in comparable interface, we have one method we call compareTo that must be implemented, and this method will return a negative integers if it compares and see that the object that being compared is less than. If it's equals, that means they both are equals. If the object being compared is greater than, then it returns the positive values. So this compareTo just similarly the one that we use in string class. So let's see how we're going to implement this in compareTo in circle. So we said if this dot radius less than circle dot radius, return -1. So this dot radius mean it owns to compare to the object here from circle. So the object being compared to is this circle happen to be greater than, so that's why returns -1, because it owns is less than the object. Now if it's being equals, it returns 0, else it's going to return 1. That means the object, our own object, is greater than the object that we're comparing to. So note that the equals method and the compareTo method of our circle class are compatible with each other. To simplify discussion, we sometimes refer to the attribute or combination of attributes of an object used by the compareTo method to determine the logical order of a collection as the key of the collection. So we use the attributes like radius to compare. Now we understand the basic of objects references, and when we compare we have to use the method equals, not to equals operator. And if we want to get the order, we need to have use compareTo, and the class must implement compatible. So let's look at an example. Alright, so we have the users class, and we want to make sure that user implements compatible. Then we can start to use user to compare. When we insert the user into the list, then we want to make an order list. So one method that it must implement is compareTo. We also have equals, and we said we gonna sort the user by, let's see how do we sort the user by. Let's look at requirements. So if you can sort by multiple fields, order by gender, date of birth, and username. Right. So first, let's look at if we sort by. So this is the code that's showing we sort by username. Right. So let's test just the username first. Okay. So the code is already compareTo by username. Now, how do we use this when we insert into the list? Right, we already implement compareTo from compatible interface. So let's start to look at, we're going to create a list. So let's review the list first. So like we said, lists exhibit a linear relationship among the elements. Each element except the first has a unique predecessors. Each element except the last has a unique successors. And we have the size that keep tracking how many elements on the list. And it can be varied over time. And there are three types of lists: unsorted, sorted, and indexed. Unsorted, that means list is in order. Or sorted is list in order. Index is we have an index to identify the list, like ID of the user can be an index. Alright, so we're going to look at the list that we will look at. It is unbounded. That means the size not limited. We can insert as many as we wish to the list. In this, we allow the duplicate elements on our list. Okay, but for our assignments that we look at here, we do not allow duplicates. So that means you have to check first. We do not support null elements. So we cannot insert null into the list. That means no data, null. Other than prohibiting null elements, we have minimum preconditions on our operations. Our sorted lists are sorted in increasing order, and compareTo is going to help. Equals and compareTo methods of our sorted list elements are consistent. If we talk about indexed list, the indices in use at any given time are contiguous, starting at 0. So we define a small but useful set of operations for use with our lists. Capture the formal specification of our List ADT using the Java interface construct. Pull common list method descriptions together into a single interface called List interface. So we can use interface, right, to construct the operations. Extend the list interface with a separate interface for indexed lists, since indexing a list allows additional operations. List iteration. List has a linear relationship. We can support iteration. Iteration means that we provide a mechanism to process the entire list, element by element. From the first to the last, we have reset and get next. Reset pretty much just initialize the list, set the current position to the first element of the list. Get next return the next elements and updates the current position. So those are the operations that we can look at: size, add, contains, remove, get, toString, reset, and get next. This is for indexed list. We can add to the specified index. We can set to specified index. Get from the index and return the object back. Remove, index of. Let me put the object, return index of that object. Remove from the index specified. So this is an interface that we're looking at, right? List interface with the operation that we just defined it, and extends an interface to have add, set, get, index of, and remove. So let's check our code here. So we're going to look at utils where we have the iList, right? And iList, let's compare back to our operations. So we have add void t element, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So What's different here?